So we're going to attempt today. I'll try to be nice.
So we are making chain link,
We're
right?
doing chain links today. So what Rufus just passed around, that is an example of a good chain link right now, or at least as good as we have gotten thus far. Once that one's around, I got some other ones to show you possible failures.
Possible?
Probable?
Failures that are possible and others may make the
Oh,
change.
our examples we made of things they don't need to do?
That's exactly what it is. What you don't need to do. There are also some others here. I guess I'll pass them around a different way we looked at forging them. Here's the chain link now. Alright. So these are next to metal. So for one, what you're gonna start with is just an 8-inch piece of 3/8. This is just mild steel, nothing fancy right now. We'll bend them around to make like a U, make scarf joints, fold those over one another, and then we will start to do the forge weld process. We clean up after that. But as we were doing this, one of the things we started doing was just off the top of our heads, we decided to fold the link over and fold it over itself top to bottom, where we would have to forge it on the horn, and that's the only way we could get the forge, the weld to be forged in this case. Started looking at other videos, like what Mark Astor had done, and some other ones. They actually, or he forges them, he pulls them over one another, and he can forge straight down on the anvil, which is much easier than doing it on the horn the way we were trying the first time. So I will pass that one around to you just so you can see it as a way not to do it, but it was successful. The failures that you have seen, pretty sure both of those are mine, from what I remember. And you'll notice one, scarves didn't hold. They did not weld together, and they would be able to slide apart. The other you'll see was where the welds held, but they burnt in half just to the left of it because they got it too hot. So managing heat is pretty critical in the forge welding process. I know some of y'all have already forge welded, you know that, and for those of you that haven't forge welded yet, you're gonna learn it really quick. Cleanliness and management and time in the fire is very, very critical. So, I'll go ahead and start getting things heated up. Normally we use a normal set of tongs like you see over here, but David decided to forge me a set of tongs today.
Well, it's my fault.
Very special. They're gonna work great. It's okay, they're gonna work great. And what was interesting was he noticed this in the Mark Astor video. He used a very specific set of tongs like this. And what it allows you to do is there is a groove, horizontal in this case, that matches great with my 3/8 right now. And I can hold it, it's not going anywhere. The other deal we have is when we start, it has a groove long ways that I can also hold my piece. So very purpose built. You can probably use for a lot of other things too, but this will be very particular for making the changes. So, see where we're at. Make sure we get it fire and get it warm. The first thing we'll do is when we get it warm, we'll warm it up right in the center of the rod. And the first thing we'll do is actually make our U shape. We'll make the U. I don't have one to do right now, but we'll make this U first. And the way we'll do that, take the rod, stick it in the pressure hole, get it about halfway where you think your bend's going to be, and we'll just bend it over. Make a U. There, we'll try to even out both sides of it. One of the things I learned in this, since the weld is relatively critical, manage your fire to where you have a couple inches even above your fire line. Don't stick your piece down in the fire. It's not a good idea. A lot of oxygen down in there, you'll get a lot of scale, and that will reduce your chances of a good forge weld. You want to keep it clean, cleanliness. We won't keep on steel. We don't want to keep on iron oxide. get it somewhere down in there. That way, I'm gonna take it over. I got my U-shape, right? Just close it just a little bit. But I want to get it even. You'll notice it's not even right now. It's not a big deal right now. It's okay. We can fix it. Just going to come here and get a little more even. Get back to the barrel. One thing you'll see is it's close to even. It doesn't have to be right on the money. Just get it close. That'll be good enough for what we want to do. We have found that keeping them spread a little wider in a U rather than a straight up U is a little more helpful. So you want right now, I don't need a terribly hot fire. So we're just getting our shape right. There's no need in trying to get it to welding temperature right now. I'm not in a rush. No need to be rushed. You have a question?
So just to make sure I'm understanding you correctly, you said with the chain link, it works easier if you almost have it like the shape of a carabiner, not perfectly cylindrical, and you want your forge weld to be at the top of that so you have more room to work, right?
Very good question. Yes. The forge weld is going to be here individually. It doesn't have to necessarily be a carabiner shape, but the forge weld is on the end. And to start with, you see it's kind of V-shaped.
Yeah.
That's what has been a little easier for us to bend these over after we make our scarves later to get them to line up. A good question.
Is there a reason you don't do it on the side of the link instead of the end?
Yes.
Number one, because it's harder, and 90% of the failures we did was on the side. While we have made green gold a little bit more difficult, we still try to make it achievable, and at least as we can see it separate. Doing them on the side, it's maybe a 25, 30 at best.
Alright. That's about what I'm going to start with right before I make my scarves. Not perfectly straight up, not perfectly parallel to one another. Just a little offset each way. Alright. The next thing we're going to do is we're going to make our scarf. Does everyone know what a scarf is for scarf weld? Most of them do. No? Okay, so what a scarf is.
Jeremy.
Ah, that's actually perfect. Yes, that's actually good. Scarf in a weld is when we have two welds that overlap one another. You can almost think of it as like a handshake slightly. You're trying to give area for them to lock together. All right. And what you'll notice David has is how I'm going to try and make my scarf. She's actually really good. I haven't made mine look that good, but what you'll notice is there's a flat, and they're on opposite sides of that link. All right. You'll also notice there's material pressed. There's material pressed this way, in like on the inside of the link, right? So what we're going to do is once we get those scarves, we're going to bend them in slightly and lay them over one another where they will lay like this, almost. Kind of like this, in this fashion. I'm not going to make my link to where they come together in a perfectly like this. They will be pointed slightly, but that's okay, because we can finish that a little later. So, keeping it clean is paramount right now. And that's why you saw me brushing almost after every time I pulled it.
Jeremy,
Yes.
explain to the new folks what scale is and why you need to call.
Yes. That's good. So scale, I'll put it in right here. Scale is just, it's oxidation. It's not your, it's not your base parent material. That's actually a really good piece right here. Bring that over for Andrew.
Zoom out there.
Just a piece of scale right there. You notice this particular one is in the shape of the round stock we had. That came right off. I don't know if that was off the piece I was using or just, there's scale all over here. But it is, and Andy, you may be able to explain a little better, but it is the steel oxidizer. It's just something we cannot use to forge weld. It's an impurity in what we are doing. We don't want those impurities where we're going to weld because they will not weld. So, does that help? Is that good? Does everyone understand kind of what oxidation is now on the metal and what the scale is?
So what you're saying is that scale is rust made by fire instead of water.
It's a good way to explain it, yes. Rust is oxidation of a sort. There's a lot of different kinds of rust. The normal rust you'll see here is this orange rust, right? Red rust, whatever you want to call it. Some other things that I've worked with, I've actually seen black rust, and that can be beneficial in certain cases. But there's a bunch of different types of oxidation. So, and they're created by different things. The orange rust you'll see is water, kind of. That's what we're normally used to. But Rob, what you were kind of saying was the scale is created by a very fast process with heat. Heat increases the speed of that oxidation.
It's all oxygen interacting with the iron in the steel.
Yes. And the reason you don't see scale just here, when this is like this, the same kind of scale we'll see here, it's happening much faster with the heat. So that's the best explanation I can give to you. Like I said, Andrew, you'll probably have some better ones.
When in doubt, ask the chemist.
Yes, ask the chemist. Don't ask the engineers.
They both everybody already knows, but don't ask the engineer.
Don't ask the engineer.
Especially if you're in a hurry.
That's something else we're going to try to do today is I'm not going to be in a hurry on the beach. That's what's got me in trouble last time. So patience is really helpful. The next step is the bead scarf. Let me get warm right now. The scarf is important because if you watch some other videos, you'll see someone come to the corner of the animal. And that's fine. That's fine in that area. But if you look much closer, they're not actually on the corner of the anvil, they're on an edge. Where that becomes significant is when I have the edge of my anvil. If I have my corner, let me think if I make something with a corner and I start hitting it, it's going to smash out in all directions, right? I only want that leaf to come out in one direction. So what I do is I put it 45 degrees on the edge of the anvil, not the corner. You'll see the difference? Not the corner, but I want the edge. So what that allows me to do is, as I'm going and striking, I will rotate the piece, and that will allow me to make my leaf coming onto the inside. About the color temperature I want. From here, we're going to start our inside. Alright, got a little thin there, it'll still work. Alright. So, just have my two scarves. They're not beautiful, they will work. Scarf right here. You notice they're on opposite sides. This one flattened out a little too much, but see the scarf before. Now you pull yours. scarf right there. It's hard to see. There we go. Then you see the flat scarf there. Now I'm gonna flatten that a little too much. See the difference there. It'll still weld. It'll work. See the scarf there. Like I said, this one's not great, but it will work. Scarf there, see the opposite. Keeping the fire deep is helpful. The weld particularly. So the next step in the process will be taking those scarf joints we made and pulling them in over one another. Kind of like this actually. We're going to do this right here. Alright? The leaves I have on the inside, it's kind of hard to shake my hands like that. But instead of them being this way, they're actually, the leaf is in towards the rest of the length. You'll see that when I actually fold them over, and I'll bring it around for y'all to see that. So, one way to get a little more airflow is there's something called a clinker breaker down on the bottom of the forge. And it's like a little cylinder that partially controls airflow, but it also breaks up what we call clinker at the bottom. Clinker will form, and it will suck all the heat out of the fire. This is a piece of clinker. I actually made this one last night, I remember. Clinker is
A silicate.
yes. You're not going to burn that. That's not a fuel. Not like coal or coke. We start with coal, but our fuel is coke. A little bit of a difference there being coal has a bunch of oils and a bunch of other junk in it that it'll ignite. But coke is the fuel that we burn that doesn't have all the rest of that oil in there in the fire.
Clinker actually acts as a heat sink in the middle of your fire. Instead of it getting hot, it sucks the heat out of the rest of the fire.
Probably have a piece of clinker at some point in this class I'll pull out of here for this demo that I'll pull out. You'll be able to see how it's made. I started with no clinker in the bottom of that. Relatively fresh coal and coke that we had from last night. So this is still not exactly where I want it to be, but y'all can see kind of where we are in the process, how fast it's heating up.
What type of coal are you using, guys?
This, I'm glad you asked that actually. So normally we use over there that in the corner, that is bituminous coal. It has oil and several other things in it that we burn out before we use the coke. That's where you get the yellowish greenish smoke from and the same green coal. That particular right there is something we have on trying out. That is anthracite, which doesn't necessarily have all the oil and all that in it. And it does burn a little different. I haven't noticed that much of a difference here because I'm using both our normal coal and that. But bituminous is the best answer for that. Okay. So
It's all yellow.
come here, start bending these over a little bit. scarves back where I want them. Right now it's all about manipulating metal to get the scarves aligned where I want them. Just have to get close. That's perfect. I'm fine with this. And we're going to keep it clean as best we can.
What's the point of having them angled like that rather than play glass across?
The way I make these scarf joints and the way I've seen demonstrated. So if I make the scarf straight, I would want to do this, right? And turn the length all the way in. The scarves I have now, imagine, start to do it, but imagine a tag coming off the side of my hand right here. When I do that, they'll fold into each other and my tag will be laying over the other side. So I don't have to bring it over all the way. I can have it at my angle and still have a lot more area for that. Does that help make sense?
That's actually done on purpose.
Yeah, I mean, that's the point of the scarf.
So you're saying a greater surface area, more chance of forge weld.
Yes, that'd be the,
Greater surface area, stronger forgeweld.
Because if it's too thin, it's not gonna be it may weld, but it's not gonna be a very strong weld.
So,
What's the point of a piece
see my
of jack?
scars? It's actually not perfect, but it'll work. So you see how my scars are kind of laying over one another?
That's also the reason why
Yeah.
the weld is on the end of it rather than the middle, because with the forge weld,
Okay.
being on the side is more apt to fail apart than being on the end.
Scarf isn't perfect, but it will weld. I'm gonna make it weld. Yeah, they're kind of laying over one another right there.
Will it weld?
so I don't have to.
Yeah, we spent about a month working on just this process, trying to get it to where we can teach it, where y'all can walk through it. You'll see the pile of mistakes that we still have sitting here. There were many more mistakes than that.
Okay. Next comes the fun part. Get ready for the weld.
Step one.
So, a little fire maintenance. So just kind of prepare y'all for the weld. When we forge weld, we use flux.
Brian, you pull one of them charts off that board back there. Pull the big one if you can.
That one, yeah.
That one.
Now you're getting all fancy.
You said it's a mild steel. These are just mild steel. So steel that you see in a real like logging machine will be a higher carbon. A little different than what we're using. These aren't made for any type of load bearing. At least not heavy load bearing. So. Okay, so we're gonna forge somewhere in this range right about here. Kind of yellow, orangish, around in there, right? That's what you saw me forging at earlier. And this is totally by sight of eye. But each of these colors represents a temperature range. And normally we're forging around 2,000, 2,300 degrees F, somewhere around there. When we go to weld, I'm gonna be forging all the way up here where it's 26, 27, 2,800 degrees F. where it's almost yellowish white. You'll see, you're probably gonna see a spark or two today, which is burning. We don't necessarily want the burning, but we do want it hot enough that the metal will fuse together.
Andy, you probably want to scoot back just a little bit.
Yeah. So, oh yeah.
So, you notice it's kind of dim in here? It's not a bright place, you don't want to read a newspaper in here. And that's by design. If you go to blacksmith shops, historically, they're kind of dim places. And they're that way for a reason. It's so the smith can see the color of his iron without too bright a light on it. If we had like serious spotlights and all, Jeremy could never tell what temperature his workpiece is at. So that's kind of why things are dim in here, it's so you can see the color, because the light comes from the object rather than being reflected from the incident light.
That's why it's hard to daytime outside.
Yeah,
You
it's
see like
almost,
forge and fire, they forge weldings, they're outside.
Y'all see about how hot that is? Sorry to interrupt, but this is kind of pretty cool. So that's what it was when I pulled it out, was about the temperature I want. We're gonna clean it. And this is where speed comes into play a little more. This is flux.
Usually a borax based.
Yes, this is a little different from flux, but we can use borax to do the same thing. What flux will do, we want to get it all in the grooves where my weld's going to be, and it's going to end up pulling impurities out when I make it. You'll probably also notice the fire is a lot brighter, a lot hotter right now. I can feel a lot more heat coming at me. There are safety glasses behind y'all. You don't have any. When I get ready to do this weld, it will splatter. I'm sure y'all know. It may not be a huge splatter, but it will splatter. When I do a forge weld, we don't want to go and obliterate the metal with stripes. We don't want to go crazy with it. Your first couple welds, you're just going to need some light taps. You're setting the weld. Get it too hard, if it gets too cold, you can actually just pull that weld apart. So, there's also no reason to necessarily stare in the fire either, because now there's a spot right where you are, everywhere I'm looking at y'all. I can't see your faces anymore. But sometimes you time it. We may have another 5 seconds on this one, maybe. That's where I want it, right here. We work both sides. I'm going to clean it. I'm going to bring this around so y'all can see this step.
Who knows why you see those sparks?
The sparks are the borax flying out, the flux.
The flux, has anybody ever soldered two wires
It is one
together?
piece now.
Anybody ever soldered copper together?
It's actually a little hard for me to see because I still got a sunspot right where my eyes are. But
Keep that metal clean.
I got it. Oh, yeah.
yeah,
When you see those sparks flying out, that's all the impurities and all the mess that you don't want. That's gonna keep you from making a forge
so it
weld,
is.
leaving the area.
Stuck.
It is welded.
Yep.
We have a weld for now. I can destroy this weld by getting it too hot or getting it too cold. It's actually cooled down to a red. It's still hot, but you can see the lines there. They're starting to blend in. Y'all may be able to see there, I can't. I still have a spot right there. I can't.
You're doing so good. We're so proud.
Did anybody notice at what pace he was moving while he was just doing regular forging? He was doing kind of slow, kind of methodical. At what pace did he move by the time he knew he had that piece of metal hot and he started to hit it? You've got about 3 seconds between that fire and that anvil and that first strike. Before impurities and oxygen start trying to get back in the middle of that weld.
Cleanliness is very important right now. On every surface that I want welded. Getting all impurities out if I can. And just give you an idea. That's kind of what when I get it clean. It's not going to look beautiful, but it gets a little shinier. See right there? It just knocks some of it off. It's not going to look absolutely perfect. But just to give you an idea of what the cleaning actually does. The look, it's not. It's something I've had. Something I've had a hard time with, Rufus has been helping me with. You notice where I have it in the fire. I don't have it deep down in there. I don't have it down in the bottom of the fire pit. The fire pit actually goes below the hearth right here. It goes below the hearth about 3 or 4 inches. That fire pit itself on the top is about this big around, and it slants down to the sides too much weird where all the air and everything goes up.
Oh yeah.
See my sparkler? Sparkler's not necessarily what I want. But alright, get my flux on there. And you'll see that flux is melted in. See it's still melting right there. The flux is turning into like a glass, you'd say.
Yeah.
That's actually what it would look like when if you have enough light to see it. But that's just to show you what it's going to look like when it flux. And it's actually all melted by the time I've got everything off by now. But you can see some of you can kind of see some of it shining there. But it turns into like a glass. So, and as it turns into a glass and that liquid, it's going to go into all the grooves. And as it goes into those grooves, when I go to get it hot again and strike, I'm going to knock out a lot of those impurities. The flux will carry those impurities out with it.
Now I'm gonna ask an obvious question.
Yes.
The answer should demonstrate that whether why we appreciate this journey of smithing. But would it not be easier to go to Lowe's and buy this chain?
It'll be drastically
You think it's easier to go to Lowe's and use a chain? Well, I'll do that. So maybe blacksmithing is not the issue. But it's not about the ease, it's not about, it's about making something that's going to last. Your brand, your DNA. Sometimes you're clever. You're clever.
You know what happens when it's just sitting on the fire and you walk away from it? That's another thing I'll go ahead and teach you right now. Don't stick something in the fire and walk away from it. You know how many leaves I've burned off in class because of that? How many times I've had to remake leaves in classes because of that? Yeah, don't walk away from it. Especially burning as hot as we are right now, trying to build. I put metal today at Rufus. Definitely keep it from burning.
No, you're not.
Like I said, it may even be good to have tinted glasses if you do a lot of forge welding, because there's still a sunspot right here everywhere I look at y'all. So. Alright. Both sides. Over here on the horn. Let me squeeze this up a little bit. Alright, now it's too cold. That doesn't look too cold, but it is. This is too cold to continue on a forge weld. The forge weld must remain hot when you're working on it. Not too hot. Good point, not too hot. But this is too cold. Normally, we would forge at this temperature. This is too cold. But you can see the weld. looks like it's
Still like
better.
2,300 degrees.
Oh, yeah. Still close to 2000 F. Just under it, possibly.
The key is if he was to hit that at that temperature, that forge weld is probably gonna unstick itself.
see some of the weld surface here, right there.
There's nothing near as frustrating as getting a forge weld and then you mess it up and unsticking it.
And the difference in the colors. That's part of the weld, so I can continue to work on that. That's part of the weld right there. That's part of it. So I'll continue to work on this. And when I say continue to work on it, I'll go back and I'll flux it again. You know, I'll continue. It is working out pretty good right now. It's doing good. Yeah, oh, yeah. See how many links we've been through.
What do you think? Like one more time in the fire, or?
Yeah, I'm going to continue to work on this forge weld to see if I can make some of those other lines go away. And also clean up. Instead of having a point on it, I'm going to try and clean it up a little more. The point doesn't necessarily matter on it. The point of this is to show a weld on a chain link that's sticky. This chain link is not meant for hauling logs. This isn't meant for pulling a truck. I would not trust it for that. Being mild steel, very low carbon, if any. So you notice this is a much finer coal than some of the other stuff we passed around earlier. Coal we're trying, but it sounds like Rice
So we
Krispies.
did good.
Sounds like Rice Krispies.
Where'd you get that from?
It was actually donated by one of our members, it was given to them.
You can get it at TSC. They have to order it.
TSC Union City usually keeps it at these sides.
If you look at the bag, it says rice bowl. If you listen to it, it sounds like it's running rock. That works pretty good.
Is it rice bowl?
Yeah.
Trying to get light.
Yeah.
Hard to start.
Yeah.
And you don't want to use
But-
it with a hand crank blower.
But it burns hotter.
It will burn hard.
Unless you got somebody sitting there in the hand crank like
You might want to move your brush. You might want to move your.
I'm gonna brush it real quick before I do
Okay.
it, because this rice bowl is
Okay.
sticking on. Don't be afraid to let your tools drop on the floor. It's not gonna hurt anything. Like you saw me chuck the brush on the floor. Put your speed. So point, I'm gonna say my weld is done. I am going to get it in a little more of an oval shape, and then we're gonna test it and see if it's stuck. That's the moment of truth. But we'll keep it that bright orange because of my weld.
Woo! Ooh. That's giving off some. That's more of a straw yellow.
Shape it up a little bit. Just get my oval length.
Mm-hmm.
And I'm gonna clean it up. Just a little bit. You can actually watch the scale form. And take your temperature. You notice I keep going back and brushing the exact same space. Because it's forming that quickly. Okay.
Okay.
Yeah, I'm okay with this. All right. That'll be what I'm calling finished for now. I actually don't really see my weld lines. I'm okay with this. So, I'm happy with this. I think this will stick.
I prefer it without the light if you can.
Oh, you do? Yes, yes.
Yeah, it's like, I can. Yeah, there. Looking good. Down.
My weld lines did clean up.
Whew.
Thank you.
Yeah, sorry.
Thank you. We're about to test it in just a second.
Is that in the way?
Oh, yes. Oh, yes.
It's got the laser pointer on it too.
Oh, yes. The orange makes it where I can't lose it as easy.
Did you get the red laser, green laser, or the blue laser?
It's only two.
No, they have all three of them.
Oh, this is an older one. It's still surviving, so, okay.
I don't know the lights.
Finishing this. Remember the word about it on the beyond. I want to solidify my weld. One, you don't want to test your weld hot. You test it hot, you're definitely gonna pull it apart at the same time. You're not gonna be using the chain while it's hot anyways. Most likely, if you're in a very odd situation. But, so, to see if our weld is good, we want to understand, I've welded in, if you look at how it's oriented now, I've welded this way, right? I want to know if my weld's going to slip apart. Not worried about this way, it ain't going to go that way. Most likely not going to come apart, it can slip apart. I want to know if it's going to slip apart. So that determines the direction in which I actually test my weld. So I'm not going to test my weld on the end. Done that before, bad idea, you'll break it every time. I'm going to test it on the side. And
Did it fit?
Yeah.
stuck well.
Okay. Yeah.
It's it.
Now, when you hit that with a hammer, you were afraid and
Oh,
really.
very much. Very much.
Please hold together, please hold together.
Yeah, seemed confident, but there was a little bit of wonder there.
Yes, I'm speaking from personal experience.
So that is chain link. I'm not gonna do the rest,
Okay.
but other that is you make a second link, and we take our third link, and you'll end up welding them together. that way, so now you have 3 chain links, and you just keep continuing that process to get the link that you want.
Have them do multiple links all done together, or do you always have them do this one?
Oh no, we're gonna do 3. We're gonna do 3. So we're gonna
Reason why we're
do,
doing 3.
so we're doing 3, 1, because yes, we get 1 chain link, we make 1 weld, but we also need to test it, right? So I need a second link to test it, and then what we'll do is we'll hook it on like an anvil and drag it across the floor and show, hey, my weld's held. The third link is a cool one. We're gonna start making a chain of all our members, and they will each put a link on it with their touch mark, so we can continue and show how many members we have at our forge.
Picasso, I like it.
Thank you, thank you. The chain link I thought of, he thought of the continuing weld and bringing all the members together in one big chain. So
You made that sound really, really good.
what?
The people who have already gone through Green Coal and are already members, can we make it a link to put on the chain?
Say that one more time.
The people that have already gone through Green Coal and are already members, can we make it a link to go on that chain as well?
Of course.
I think we're gonna
You know
need,
how to forge weld, right? You take a green coal, you know how to forge weld.
I think Chuck should be the first one, the first link in the chain.
Yeah.
I think Chuck should be the first link in the chain.
Well,
I
remember,
second that.
There we go.
remember I said we all stand on the shoulders of the giants that came before us? Somebody taught me too.
Well,
We're gonna need a much bigger link of chain out of you, Chuck.
You're gonna be Jacob Barley over there, Rufus.
No.
Rattling the chain, Walter.
We just need a bigger link out of you, so we can say that was Chuck's, he started this mess.
You don't want me to be the missing one.
okay. Well,
All right, any questions, thoughts, complaints?
No.
He takes complaints.
that's all. Let's all thank Jeremy.
Good job, Pat.